Okay, this lesson is on radicals, otherwise known as square roots. This is not in your book, but it's a really, really important topic moving forward, so I need to talk about it. The first thing is you have to understand what a square root is. Before you can understand what a square root is, you have to understand what a perfect square is. We've talked about this in factoring, but your perfect squares are any numbers that when you multiply another number by itself, you get the perfect square. So here are some examples of perfect squares. Okay, you should memorize your perfect squares up to about 15 squared. Let me do them for you so you can study them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is 144. 13 is 169. 14 is, good question, 196. And 15 is 225. Let me check that 14 one. I'm pretty sure that's right. It's been a while since I've had these memorized. Yep. So you have to know all of those so that if you come up on a problem that says square root of 144, you can say, oh, that's 12. The square root means find the number that you multiplied by itself to get these perfect squares. So the first thing you have to know is all the perfect squares. So memorize those. Now, sometimes you're going to have a number under a square root that's not a perfect square. For instance, 2 and 8 are not perfect squares. So we have to learn how to simplify them. It's kind of like factoring. You're taking something and you're breaking it down into simpler terms. But there's some rules you have to know first. The first rule is when you multiply something under a radical by something else under a radical, you simply keep the radical and multiply the numbers underneath, which gives you the square root of 16. Well, what is the square root of 16? The square root of 16 is 4. Now, a common mistake is to write this. Oh, the square root of 16 is the square root of 4. That is absolutely not true. The square root of 16 is 4, the number 4. And if we look at a calculator and we type in the square root of 2 times the square root of 8, it's going to say 4. Let's look if this ever opens. So let's clear all this. Square root is above x squared. Square root of 2 times square root of 8. It's going to say 4. Okay, that's what we just talked about right there. Another important thing for you to understand is that when you multiply a square root by itself, you get the number underneath. So for instance, we just said the square root of 8 times the square root of 8 is the square root of 64. Which is 8. So another rule to remember moving forward is when you multiply a square root by itself, you just get the number underneath. Because what you're doing, this squared here, wow, I need to align my thing. This squared basically undoes the square root. You're saying square root of 9 times square root of 9 is 9, because it's the square root of 81, which is 9. Hopefully that makes sense. Let's move on to some more. Now we're going to start simplifying square roots. So the square root of 18 is some really big nasty decimal, but we're going to have it within other expressions and we need it down to its simplest form. It's kind of like saying that 20 over 8 reduces to, reduced by 4, so it reduces to 5 over 2. Okay, it's kind of the same thing, we're just reducing it. There's two ways to go about it. Some people like to say, what's the biggest perfect square that goes into 18? Well, if you think about that, you have to memorize all of your perfect squares, 1, 4, 9, 16. And you would start with the smallest one, the biggest one that's smaller than 18. So like you would say, does 16 go into 18? No. Does 9 go into 18? Yes. So we could rewrite this square root as the square root of 9 times the square root of 2. Because we know this value. We know that the square root of 9 is 3. So your answer would be 3 radical 2. That's how I was taught, and that's how a lot of teachers still teach it. And if that makes sense to you, that's great. So for instance, here we would say, what's the biggest perfect square that goes into 200? The biggest perfect square that goes into 200 is 100. So we would write the square root of 100 times the square root of 2. Because remember, if you multiply the numbers under the square root, you get what you started with. Square root of 100 is 10, so your answer would be 10 root 2. Now, some people don't like this way, so let me show you the other way to go about it, simplifying a square root. And this is what most kids in high school revert back to because it always works. If I do the prime factorization of 18, pick any two numbers that go into 18. Let's say you pick 6 and 3. Okay, and then keep going down until you get all prime numbers. So 2 times 3 times 3 is the prime factorization of 18. So in order to put it in simplest radical form, you find anything you have a double of, like 3's, and you put that on the outside. Only one of them. Put one of those on the outside. Whatever's left over that you don't have a double of goes underneath the radical. Same answer we got before, but instead of using perfect squares, we used prime factorization. So you could do the same thing with 200. You could say, I know that 20 and 10 go into 200. And 20 breaks down into 5 and 4. And 4 breaks down into 2 and 2. And 10 breaks down into 2 and 5. So the prime factorization is 2 times 2 times 2 times 5 times 5 times 4. That doesn't seem right. Yeah, that's right. No, it's not. What did I do wrong? 20 times 10 is 200. 5, 4, 5, 2, 2, 5, 2, 2, 2, 5. 10 root 2. Oh, I have an extra 4 here for some reason. I don't know where that came from. Okay, that makes sense. So now what do I have doubles of? I have doubles of 2 and 5. So I take out 1, 2 and 1, 5 and write them on the outside and multiply them together. And what's left over stays under the radical. Again, we got that by saying the square root of 100 times the square root of 2 is 10 root 2. Or you can get it this way. Either way you get the same answer, but you have to be able to get down to this. Let's try another one. Now this negative outside just means that my answer is going to be negative. I bring that along for the ride. And then I simplify 32. So pick any two numbers that go into 32. How about 8 and 4? And then 4 breaks down into 2 and 2. 8 breaks down into 4 and 2. And 4 breaks down into 2 and 2. So the prime factorization is 2 times 2 times 2 times 2 times 2. How many doubles do we have? We have 2 doubles. So I take out 1, 2 from here and 1, 2 from here and put them on the outside. And I put that 2 underneath, and I make my answer negative because there was a negative out here. Let's try 250. I'll do 25 and 10. That breaks down into 5 and 5, 2 and 5. So the prime factorization is 5 times 5 times 5 times 2. So I have double 5's, so that goes on the outside, just one of them. And what's left over is 10, so that goes underneath. Let's try these. 45, I think of 9 and 5. 9 breaks down into 3 and 3. These numbers can't go down any further. I have 3 times 3 times 5. So what do I have a double of? I have a double 3, that goes on the outside. I have a 5 left over, that goes underneath. How about this one? This looks scary. I have no idea what goes into 588. I know 2 does. So 2 goes into 588, let's say 294 times. And then 2 goes into that. 2 goes into that 147 times. What goes into 147? Well, you have to play around with your numbers. I know, because I know my divisibility rules, I know that 3 goes into that. 3 goes into that 39 times, I think. 3 goes into 147. 49 times. Oops, bad math. And I know that 49 breaks down into 7 and 7. So the prime factorization of this big nasty thing, you have to look at the bottom of all of your branches. So it's 2 times 2 times 3 times 7 times 7. What do I have doubles of? I have double 2 and double 7. So I take out a 2 and a 7. I put 14 on the outside. What's left over is root 3. Now you can always check your answer by typing this into a calculator just like this. 14 square root 3 and square root 588 was what I started with. These should be the same answer. That means you did it correctly. Okay? Same thing with 150. We have 15 and 10, 5 and 3, 5 and 2. So we have 2 times 3 times 5 times 5. Take out the double 5's, put them on the outside. What's left over? 2 times 3. So 5 root 6 is my answer there. Let's try this one. 36 and 10, 5 and 2, 6 and 6. Now, you could stop here and say, I know I have 2 6's, so I'm going to put a 6 on the outside. But if that doesn't make sense to you, then let's keep going, and you can do it the way we've been doing. So 6 is 2 and 3, 6 is 2 and 3, so I'm left over with 1, 2, 3 2s, that's this, 2 3s, and a 5. So I take out a 2 and a 3 and multiply them together on the outside, and what's left over is 2 times 5, which is 10. And again, type it in the calculator, make sure they match up, make sure you didn't make a mistake. Okay? Now we're going to start throwing some variables into the mix. So, we're still going to do the prime factorization, but it's important for you to understand why this works. You have to remember that anytime you have a variable with an even exponent, like x to the 8th, that is a perfect square because it's x to the 4th times x to the 4th. Even though 8 is not a perfect square, because it's an exponent and it's even, there were two variables with exponents that got multiplied by themselves, x to the 4th times x to the 4th. When you multiply variables, you add exponents. That's where the x to the 8th comes from. So that's why we're allowed to take out the doubles of the variables. So let's look at 64. Hopefully you know that 64 is the square root of 8, but I'm not going to assume anything. I'm going to assume that you have no idea what I'm talking about, and we're just going to do what we've always done. What numbers go into 64? Well, if you don't think 8 and 8, I don't know what you think. Maybe you think 4 and 16. And 4 breaks down into 2 and 2, and 16 breaks down into 8 and 2, and 8 breaks down into 4 and 2, and 4 breaks down into 2 and 2. So 64 is 1, 2, 3, 4, 5, 6 2s. And that's it. And then the y cubed is y times y times y. So what do we have doubles of? We have 1, 2, 3 2s. So on the outside I'm going to do 2 times 2 times 2, which is 8. And I have 2 y's. So a y goes on the outside and I'm left with 1 y on the inside. So it's 8y radical y. It's okay. Okay, let's do the next one. What goes into 448? I have no idea. Actually, I know that 4 goes into it. You probably would start with 2 because it's even and that's just what you do, which is fine. But I know that 4 goes into it, so I'm going to go 448 divided by 4 is 112. I'm going to break down my 4 into 2 and 2. I'll break down 112 into 2 and 56, which I'll break down into 8 and 7, which I'll break down into 2 and 4, which I'll break down into 2 and 2. So the prime factorization of 448 is 2 times 2 times 2. That's 1, 2, 3, 1, 2, 3, 4, 5, 6 2s I need. And a 7. And then 2 A's and 2 B's. So the doubles are 1, 2, 3 2s. So 2 times 2 times 2 is 8 on the outside. 2 A's and 2 B's. So I put an A on the outside and a B on the outside, and a 7 left underneath. You might have to watch this a couple times to see what I'm doing, but it's the same thing every time. When you take out a double, you write one of them down, and you multiply everything that you wrote down together. Let's try this one, 343. Now I know that 343 is divisible by, let's say, 7. So it goes into, and then this breaks down into 7 and 7. So the prime factorization of 343 is 7 times 7 times 7. Then we have 3 A's and 3 B's. So I take out a double 7, put that on the outside. I know I have a 7 left underneath. I take out 2 A's, put one out here. I know I have an A left underneath. I take out 2 B's, put it out here. I know I have a B left underneath. So this is the prime factorization of that. 147. Didn't we just do 147? Yes. We broke it down into 3 and 49, which was 3 times 7 times 7. And then we have x, 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 y. Take out 2 x's. So I have a double 7 and a double x. So I have 7x on the outside. Underneath I have 3x, y. Okay, this is just going back to reviewing that when you have two radicals multiplied, you multiply what's underneath. So 7 times 14 is 98, and then you have to simplify your answer. So what goes into 98? Well, I know 2 goes into it 49 times, so that breaks down into 7 root 2. I wouldn't have been able to get this answer by breaking these two down, because they don't break down. Like 14 breaks down into root 7 times root 2. But I don't get any doubles when I do the prime factorization. It's just 2 times 7. So you have to do the multiplication first, always. Do the multiplication first and then break down your answer. Same thing here. I'm going to do the multiplication first. X squared times x is x cubed. Y cubed times y to the 4th is y to the 7th. Then I'll do the prime factorization, x times x times x, and then 7y's. And you're going to get good at this, so you don't have to write it out every time. 1, 2, 3, 4, 5, 6, 7. I'll take out a double x, so there's one x on the outside, and then 1, 2, 3 y's. And what's left over is xy. So this breaks down into that. Okay, so for homework tonight, you're going to have a worksheet with 10 problems on it that you have to figure out how to simplify. If you don't understand, go back and watch it again. If you still don't understand, find another video. You have to come to class on Tuesday, or whenever I see you again. For my A days, it'll be Tuesday. Understanding how to simplify radicals and what it means to simplify radicals. Okay?